All right, so we have the junior O level here. I want to focus on problem 5 today, but I thought it might be fun to pretend that like ChatGPT entered this competition. Okay.
Yes.
And see how ChatGPT would do. Okay. And that's another way of kind of going through 1 to 4. We've already gone through 1 to 4. Okay.
ChatGPT is actually really good at math.
Well, we'll see, Sebastian. Okay.
Maybe
We'll see.
not question 5.
Alright, so let me clarify the rules. So when people don't clarify the rules, it kind of can be a bit confusing because people claiming ChatGPT can solve like all these hard problems, but what is?
Say, give me a proof of this question.
Alright, so what's the rules? So we're just doing. So this is the ChatGPT 5, okay, and it's the paid version. It's not the research version, right? And I've set it to auto how long it takes to think. Yeah. So this is like, it'll give you an answer in like a minute. Okay. I don't have the pro research one. So there, you know how like people claim. You remember when IMO came out and they're claiming, oh, you could solve the IMO questions, get a gold medal or whatever. I think if that was the case, it might have been done on like the most expensive one.
What about thinking longer?
Okay, so putting it on auto. Okay, so actually just inputting the problems. Let me just show you how we input the problems. I can literally just copy the problem into the paid version. Allows you just to copy it straight in.
What? Paid version.
Paid.
It feels like this one might work.
You should pay for the pro.
So I would predict it'll give us an answer in like 55 seconds.
1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi.
Alright, stop. Shh. Do it in your head.
5 Mississippi, 6.
I said Mississippi. Why not Mississippi?
1 China, 2 China. The
One
reason
1,000.
people say Mississippi because the 4 syllables of Mississippi add up to around 1 second. It's like 1 China, China, 2 China. What do you want?
Oh,
Okay, I guess thought for 31 seconds. To put this in perspective,
they type
wait, Michael, how long did it take you to solve this?
it.
30 minutes, 20 minutes.
Like
Probably
20
like
minutes,
30
yeah.
minutes.
Okay, so it's like 1 second for a minute here. Okay. Alright, let's see if it gets it correct, okay?
They type with if. They put an extra F.
No, that's infinitely for
Yeah. Alright, let T sub D be the set of students who told the truth on day D. And L sub D, the liars, I guess also on day D. When asked, will you be telling the truth tomorrow? A student answers yes, if and only if they're lying both today and tomorrow. Does that make sense? Okay, because they can't answer yes if they're telling the truth. Because they can't tell the truth twice in a row.
What is that like curvy line that looks like?
So this means the intersection of the sets. So that the students that are both lying on day D and lying on day D plus 1. Okay, so... Alright, so what's it saying? April 1. Everyone said yes. That means L1 intersect L2 is everyone. So T1 equals T2 equals the empty set, and L2 is everyone. Okay. April 2. Half said yes. So therefore, the intersection of L2 and L3. So lying. Oh, so they kind of got like a little lemma here. So if you're saying yes, then you're lying today and tomorrow. Yeah. Okay, so half said yes, so half of the people are lying on day 2 and day 3. Yeah. L2 is everyone. Okay. So that means L3 is half, because everyone intersect L3 is just L3. Okay. So on April 3rd, half lie and half tell the truth. Okay. April 3rd. A third said yes. So that implies L3 intersect L4 is a third, yeah? So among the half who were lying on April 3rd, the fraction still lying on April 4th is a third over half, is 2/3. Thus the fraction that switched to telling the truth on April 4th is a half times this, which is a sixth. Alright, I kind of don't understand what this is saying. What is this saying?
It's saying that.
So this is true, yeah. L3 intersect L4 is a third, yeah? Among the half that were lying on April 3rd,
Yeah.
so that's
So
this half
L3.
here. So L3 is a half. So when you intersect it with L4, it has to equal a third, right?
Yeah.
So out of the half,
So basically it's saying that overall,
Yeah.
2/3 of the people who 2/3 of people in L3 are also in L4.
yeah, I guess that's what it's saying, right?
Yeah.
2/3 of the L3 people is half. Sorry, 2/3 of the 2/3 of half is a third. Yeah, that's what it's saying.
Yeah.
Yeah. So 2/3 out of these L3 people are in L4. So then there's just 1/3 of the L3 people that's not in L4, right? And 1/3 of half is a sixth. Yeah.
Yeah.
Okay. Yeah, I guess one thing they kind of did pretty clever was yes implies lying twice. Yeah. Alright, so I think they would get full marks for this. Yeah. Okay. The write-up, it's okay, yeah. It's okay. It's better than a lot of write-ups I've read for this question. Alright. You guys have any questions about this one?
Wait, what's the answer to this?
Wait, what?
What's the answer to this?
It was a sixth.
Oh, okay.
Yeah, so I guess the question kind of implies that the number of students are divisible by 6. So. Alright, let's have a look. Yeah, so ideally they would enter the competition officially and then pay us lots of money and advertise it. But we never get around to doing stuff like that. This is the best we can do. So they would in principle have what? So the competition officially is 5 hours long. Yeah. Huh? Yeah. Even though we do it for 4 hours. Even though, you see, ATT suddenly became 3 hours.
I know. Isn't it like
Alright.
only 4?
Also, I should make a note. There are people in other states who haven't done ATT, so we can't talk about the actual ATT, yeah?
Yeah. 31 seconds. It's pretty common.
It's a sketch.
What's a sketch?
Sketch means it might not be writing a proper proof. Just doing 31 seconds again.
You can just ask it write a proper proof.
I guess so.
Please.
I just don't want to spend too much time on the earlier ones. Okay, let the paved length be L and the forest be R. Yeah, Bob's speed is V on the paved and W on the forest. Do you guys remember the question?
Yes.
Okay. Yeah, so the question is there's a paved part and a forest part, and Alice runs from left to right, paved then forest. Bob runs forest, then paved. Alice's speed is always 5 times Bob's speed. Okay. Put K equals the ratio of their speed, so V over W. So do we know it's faster on the paved than the forest?
Yeah.
Yes.
We know that?
Yes, it says.
Oh.
Doesn't it tell us how much faster that is?
I feel like we never assumed that last time. Something felt like it was wrong. I feel like we never assumed that the forest was slower.
No, we did.
Did we?
To show that it was on the left.
Didn't they tell us it was on the left?
No, they told us that was 6 kilometers away, and we used that it was faster to show that it was on the left.
Really? Didn't we just need to know that Alice was faster than Bob on the forest?
No, we also needed to know that the forest was faster than. Oh well.
Okay. Alright, if the day one meeting point is X kilometers from A on the paved road, equal times give X. So Alice took this time to get to the meeting point, right? So the distance divided by the speed. And this is Bob's time. Bob had to go the entire forest, which is R over W, and then the paved path only up to L minus X. Yeah, so you get this, you know? And if you solve that, I guess, so now you have to sub you want to sub all this stuff in now, right? So here there's only L's and R's and K's. Okay, so if you times this by 3 over 2V, then this becomes 3 over 2 KR. Yeah. And then this becomes, the V just cancels, and this becomes 3 over 2 L. And then it's 3 over 2 X, right? Yeah, maybe I'll write this out. So this becomes, so X equals 3 over 2 KR plus 3 over 2 L minus 3 over 2 X, yeah? And then we collect the X's together. So that becomes 5 over 2X equals 3 over 2 KR plus 3 over 2 L. And then we cancel the 2's and we'll divide by 5, so X equals 3 over 5 KR plus 3 over 5 L. So that's what they got there, right? Okay, day 2. They meet at Y from A, also on the paved road. Now, what's this say? Okay, on Y, yeah? So they do the same kind of argument here, you know? But now Bob is the one that's traveling to Y first, on the left. So that's Y over V, and then it's R over 3 over 2W plus L minus 5 over 3 over 2V. Okay, so it's the same calculation, yeah? So then when you put the V over W, it still ends up being V over W, which is nice. So let's just do it. So Y 3 over 2, I'll times both sides by 3 over 2V. 3 over 2Y equals KR plus L minus Y. Yeah? So you plus that, you get 5 over 2Y equals KR plus L. And then you divide it, so you get 2 over 5 KR plus L. So that's correct, yeah? The two meeting points on the paved road are 6 k's apart. Oh, so this actually naturally proves that y is less than x, yeah? So it's actually on the left. The second meeting point's on the left of the first meeting point. Yeah, so you don't even have to do the absolute values. You just do y minus x or x minus y. It's a fifth of this is equal to 6. So L plus Ki equals 30. Hence, the first day meeting distance is we're looking for x in the question, right? The question is asking for x. So x is just if 1/5. So you don't need to times 5 here to give 30. You just go times this by 3 to give 18. Yeah. Okay, so it's got full marks in the first two questions. Yeah. So far, so good. I guess since it's not really using its time, we can, you only meant to do 3 questions, right?
You should do longer thinking.
No, it doesn't need it yet.
Okay, so I mean, we kind of experimented a little bit with this already, but
I think 1 and 2 are fine because they're mostly computation, which is kind of in its area.
yeah. Okay, so question 3 is an interesting one because this is the first one that really gave students trouble. Okay, like most students didn't find 1 and 2 like most of their problems were with writing up their solution. It wasn't with sort of engaging with the problem or solving the problem. Okay, so let's have a look at question 3. So this is the one where people were giving like wrong solutions, like believing they solved it when they haven't. Yeah. Not being able to solve it. So these are things that are really coming out in question 3. Okay. So yeah, also if you guys are interested, I could upgrade it to the super paid version, but I don't have any uses for it right now.
You could use it to
looks
help
good.
last Lawrence last theorem project.
Yeah. Oh, so notice it's gone over 31 seconds.
Yeah, we've broken its record.
Wait, are these actual seconds? Is my perception of time am I just cooked?
Oh wait, I did. Oh gosh.
The seconds actually go this fast?
No.
1 1000, 2 1000, 3 1000, 4 1. It is, they're like seconds.
Perception of time.
Actually it takes like at least 30 seconds for the elevator to get from bottom to top. It's like,
Wait, 30? It feels like it takes a minute.
oh yeah, it could take a minute if you're waiting for it.
It takes like 15 seconds.
What? What kind of elevator are you on?
It somehow feels like it takes a minute and 15 seconds at the same time. No,
I think, I mean, it's good that it's, so one thing is like, it'd be interesting to know when it, like if it can detect it needs to think for longer.
Edge parity. Yes. Okay, so
Alright, does everyone know what question 3 actually says?
special tiles.
So while it's doing this, I should explain it. So you got a board. It's like the tiling by dominoes. Yeah, it's kind of like tiling a chessboard by dominoes. But the only difference is it can be any rectangular board, and you tile it by dominoes once, and you tile it again by dominoes after you've tiled it once. Yeah, and it's a question about how the top layer works. So the top layer, there are these tiles that are called special. If like they're covering dominoes on the first layer in a special way. So For example, like if this is a domino and the tiles beneath it, one of them's vertical and one of them's horizontal, yeah, then that's then the blue tile equals special, yeah. And the question's asking, does there always have to be an even number of special tiles? Okay. Alright. So this one took 2 minutes. Okay, so that's 4 times the time. So yes, the number of special tiles is always even. Reason, invariant bicycles. Fix the bottom tiling. Call an edge of the unit grid HV if on the 2 sides of that edge the bottom tiles have different orientations.
Oh no.
What's invariant by
That means it doesn't change regardless of the way it's arranged.
So HV is sort of like the
Horizontal, vertical.
yeah, HV is like the middle of where like a special tile would go, yeah. But at the moment, it's only talking about the edges because there are no top tiles, yeah. Okay, so HV maybe is horizontal, vertical. If on the 2 sides of that edge, the bottom tiles have different orientations, one vertical and one horizontal. These HV edges form a disjoint union of closed rectilinear cycles. Okay, that doesn't make sense. I don't actually know what that means.
I've never heard that word. This is a legal language.
I don't know if we need to. Okay, so form a disjoint union of closure. At every grid vertex, 0 or 2 such edges meet. So there are no endpoints. Okay, so this line doesn't really make sense. You know? Disjoint union of closed rectilinear cycles. Okay. A top layer is special if and only if the edge between its 2 squares is a HV edge of the bottom tile. Thus, the special tiles are in one-to-one correspondence with the HV edges that the top tiling chooses. Restrict attention to a single HV cycle, C. Traverse C edge by edge. Along C, the top tiling may choose some of the cycle's edges. Those correspond to special tiles. But on a cycle, chosen edges must occur in pairs. Why is that? After the top tiling takes one edge of C, the adjacent squares on both sides of that edge are already matched. So the next time the matching uses the edge of C, it must re-enter the cycle to keep the matching consistent.
What?
Hence the cycle is left and re-entered an even number of times. Therefore, on each cycle, the number of edges C chosen by the top tiling is even. Finally, the whole set of HV edges is a disjoint union of such cycles, so the total number of... Yeah.
I got lost when it started talking about HV's edges.
Yeah, so...
It's a disjoint union.
So it has some good ideas. So I don't know if you remember seeing the actual solution we had last week, right? It's clear that the solution we had last week was better, you know? It was much easier to understand and it was much simpler. So here they're claiming something about these cycles, but they don't really prove it, yeah? So they're kind of writing stuff that maybe not considered a proof. Though we never asked for a proof, so maybe we could specify we want a bit better. But our focus isn't on this question, so we're gonna still move on. So we may give it the benefit of the doubt, but as it's written here, it's not gonna get full marks. Okay. So the answer is yes, but it needs to be a proof. Though we didn't really ask for a proof. So we don't let's not be too harsh on it, but as it's written, it wouldn't get full marks. Okay. I'll definitely get marks. It picked correct invariance. It have the right conclusion, but so this thing might even be true, but it's not really a proof, you know. And then it kind of summarizes its argument. It's not an essay, you know. Okay, but it did know to think more. Okay, let's have a look at the next two questions. So I won't spend too much time on this one, but question 4 was, I feel like, a little bit out of place, though.
Felt like a Q1 or a Q2.
So, I mean, you'd be surprised to know, like, a lot of people started on Q4. Like, they just did Q4 first, or Q3 first, or like they did Q4, and they claimed to do Q4 in like 15 minutes. Okay.
I mean, like, it wasn't that hard. Just have to create an example. And it's like, it's not that hard.
Yeah.
Well,
So
it took 11 seconds. Oh,
so
not yet.
so it's kind of a weird question in the sense that, like, so let's talk about the people doing it. So people could get this question really quickly, so it meant that they probably, like, it might be too easy to guess. Yeah. Some people figured it out, like Andy said, by problem solving. Okay, and you might be surprised to learn Gregory couldn't solve this problem. Okay, so he actually spent his time on this question, got stuck on it, skipped to question 5, and finished question 5, which was much harder. It was just objectively a harder question, question 5. Yeah.
Oh my.
So this question might not be the greatest exam question. It's creating too much variance.
It's thinking that there is a problem. It's saying color contradictions. But it's not a contradiction. It's easy. It just create an example.
Alright, does everyone know the problem statement here? So we take all the natural numbers, right? And we got to color every number red, blue, or white. Okay? And the property it has to satisfy is anytime you add up 99 blue numbers, it has to give you a red number. Anytime you add up 99 red numbers, it has to give you a blue number. That's the only conditions. Okay?
Oh.
So,
my holy.
see, it's thought longer than the first two questions now already. Yeah? So it's kind of interesting how long it thinks about stuff, because you kind of sort of see if there is sort of a, I mean, we know there is a hierarchy for the difficulty of the questions, right?
Wait, is this correct?
Oh no.
Is it finished?
No.
Is it correct?
No.
This is wrong, yeah.
Oh, it's supposed to be yes.
Well, we'll have a look at it. It's definitely possible.
Yeah, so I think one of the big problems with ChatGPT is not that, like, it presents a wrong answer just as if it's right. That's the main problem. You understand? So to counteract getting the right answer quickly, it's also getting the wrong answer quickly, right? And if you can't be sure it's right or wrong, then it's almost like you have to kind of assume it's wrong almost, you know, or you have to have an ability to see if the answer is right yourself. You know? Yeah. It's like people think they're doing well in maths, like, oh, they get 95% in all their tests. But then it's like, if someone really needs to count on you, they might not be comfortable that you make 5% mistakes. You know what I'm saying? Okay, so
counting on AI.
So that's roughly the same amount of time as the other one, right? 2 minutes. No, it's impossible. Sketch of contradiction. Pick any multi-set of 99 red numbers and let 99
R is blue.
R is the sum.
Oh my gosh.
So capital R is blue. Pick any multi-set of blue numbers and let B equals that. So multi-set just means it can repeat. You know? It's a set, but the elements could repeat. Okay. And it's not really like very common language either. It's just... Okay, so B is red. For each I, the number Ri plus 98B, what's this?
B is red. That's
B
why.
is red. Is the sum of 99 red numbers, hence it's blue. Summing these 99 blue numbers gives...
Why does it feel like it's trying to prove it?
It's like...
I was just saying.
It's
So
trying
this
to
is
find
blue.
multi-sets of multi-sets.
Which
I'm
must
so blind.
there be red. Okay. So here. Alright, what's it trying to do here? So it's got, this is already blue, right? And these are reds. And this whole thing must be red. Yeah? For each J, the blue plus these blues is red. So summing up these reds is blue. Okay. From 1, since this is red, adding 98B produces something blue. Yeah? So this is red. Now repeat the argument with A and B in place of R and B. Now repeat the argument with A and B in place of R and B.
What?
What does that mean?
Why can't you just use R and B?
Blue. Exactly the same calculation yields simultaneously that
Oh, no.
R plus 9800B is red. I think you get a much bigger number, right? If you use this.
Exactly.
Okay. Yeah. So the dangerous thing about it is not that it can't solve it, it's that it presents a wrong solution like it's correct. You know?
And now for the real deal. Oh, so give it a dislike.
Wow, where?
Oh, yes.
Well, it's helpful up to there. It's helpful. See, now I'm confused.
Dislike the solution is dislike the prompt.
Oh.
Not factually correct. There we go. Well, thank you for your feedback. It's not gonna change it, but you can input your
Is
solution.
there written solution like the AIMO solutions?
I have some solutions of this on video.
Oh, okay.
A bunch of students got it.
It was sure.
Okay.
What example did you use for it? What 100? I used mod 5.
Alright, this is the final boss.
Mod 6 and mod 7.
So maybe that is kind of interesting. Maybe that's one justification for putting question 4 after question 3, right?
What the
ChatGPT.
AI generate TST? That's one. Maybe they're just trying to trip you up. Oh, is that why? Is it trying to make it AI proof or something? So that it maybe just make it like student proof. Like let's say you're like a person like Gregory and they're like, oh, I just grinded out Q3. It was like a little hard. Q4 must be really hard because it's got so many marks. And then I started grinding out with my Sigma mindset and I can't solve it. Oh, so I like failed.
Alright, so maybe I'll explain what the question's asking while we're waiting. So basically, it's asking if we can get a rectangle. So it's some rectangle. It doesn't have to be a random rectangle. It can be one that you pick, right? And there just needs to be some alpha. And you can break up the rectangle into these isosceles trapeziums with alpha. So these are parallel. And see if you can break it up. Okay. 51 seconds. Jeez.
Confidence. 51.
Wait, A equals 45 degrees, that's right.
Start with a rectangle whose top and bottom are horizontal.
Alright.
Sure. I'm gonna draw this. Divide into several horizontal. Huh? What does that mean?
Okay, so let's just see what it's saying.
What does it mean by?
Start with a rectangle
But it's
whose top and bottom a horizontal. Divide it into several horizontal strips of equal height. Like
Yes,
this.
we have to sawtooth it.
What sort?
I don't know exactly. I like how you just said several.
So the broken lines meet on each side of the rectangle. The regions between the two consecutive teeth and the bounding horizontal
Can you
lines.
provide an image?
I mean, I think it's just wrong, you know.
Just ask it to provide an image, because this is kind of unclear.
Can you provide an image?
Is there any like some?
Would you recommend Plus, like GPT Plus?
Is this GPT Plus?
Would you recommend it?
I think so, yeah. I would.
How much is it?
I can't remember, but it's less than $100 a month.
Getting started. That's a lot.
What do you mean?
Actually, no, I pay for the economist. It's
Go
not
to
that much.
Yeah, if you subscribe to an art magazine, then
I have enough money to subscribe to ChatGPT. Look, why are you subscribing to magazines?
Wait, is the
Oh.
rectangle counted?
to be fair, images are not the strength of ChatGPT.
Those are triangles!
There's a triangle.
Let's go!
Yeah, I think these are the wrong shapes.
Oh my Sigma! Oh my god! Tell it that
Alright.
it needs to be triangles.
Can you think about it for longer and produce
There are
a
67 seconds.
correct
No,
proof
51. How did you
of
think
this? Currently, it is incorrect.
Wait, have you not told it that it's a trap? I didn't wait to see if it's
No, it already knows it's a trapeze.
I mean, it might also not have produced the image that it thought it was producing. Like that does happen quite a lot.
Oh yeah. As you can see, I have produced an obvious full glass bottle.
I have gleaned it from the depths of my mind.
Clarifying the proof, refining the proof, refining the construction.
Wait, I can't. What?
Wrong guy.
Wrong guy!
Anyway, it should always be.
Also, is a rhombus a trapezoid? No.
No, it is.
A trapezoid is like the American way of saying trapezium.
Wait, what is a trapezium though? Like,
Trapezium is just like one pair of parallel. So a rhombus is a trapezium.
but
that's
it's
one
two.
pair of
Also
parallel.
one plus pair.
It's like a square is a rectangle. A rectangle. A rectangle is also a trapezium.
Yeah, but what's it for a trapezium? It only has to be at least one pair of sides parallel. Formalizing the trapezium construction. Let's go.
It's still stuck on the same. It thinks that idea is right. That's the problem.
Ideal.
Wait, it's wrong? No, chevron pattern. What's a chevron? No. Hold on.
Claim there
I
exists.
accidentally started clicking my emergency. Hey, oh no!
So alpha equals 60 is definitely wrong.
Oh no! Oh no!
And it's only 1 minute and 26 again. I told it to think longer. What if I said thinking? Okay.
It doesn't work because of corners.
You can use non-congruent trapeziums.
What did he get? What did he get?
A equals 60. Alpha equals 60.
Oh.
Oh, now it's thinking. Yay, finally.
It's finally thinking.
But if you think about it, technically it's not really a fair sort of thing. Because like you're using the thinking version. Not just
Evaluating trapezium angle. No, we're not testing the research for.
Yeah, I mean, ideally, if we were gonna give it like the same entry, like we'd be like, oh, you have 4 hours or something to do this. But But also, if you think about when people claim ChatGPT can do this, people like when they listen to that, they think, oh, that's the one this one that gives the answer in 2 minutes, right? So it's not completely unfair to put it on 2-minute thinking, you know.
Wait, did Australia stop like stop you from downloading DeepSeek?
I don't know.
What?
Why?
That was America.
Why? It's DeepSeek. What's wrong with DeepSeek?
Chilling.
Tiling, come on.
We are tilling the fields.
Silly.
Reevaluating.
Wait, so just reevaluating it consistently. Well, I just thought of an immensely intelligent
Reevaluating
solution.
happens with tilling.
Oh, I didn't read the question again because it feels too good to be true. I'm so slowly stripping things. Let's do it. Come on. Come on. Come on.
Is it? Go for longer than one thing.
Come on. Go.
Wow. It took 1
It's
2
fine.
minutes now because of the
If
other.
it fails, it fails. Oh well.
Because of the other cookies.
Isn't that just a solution? It has to be
might still take up to
isosceles.
minutes, it hasn't cost me minutes yet.
It has.
No, it says 1 minute 50.
Yeah, but plus the other time.
Oh.
Ah.
But I also think that these two have to be the same. Yeah.
Oh,
Yeah, I'm gonna kill myself now. Meow, 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 meow. It's just reevaluating the same trapezoidal timing approach. When is the point when it would realize that it may be incorrect?
Yeah, I guess also it might be funny, like, if we look at like student solutions and they just look exactly like the ChatGPT output, it might be a bit suspicious.
ChatGPT.
I mean, they would have gone the first 2 questions.
Alright.
Yeah, so I think people were cheating long before ChatGPT
No,
5.
it is impossible. Oh. Yes, but this solution that sounded promising.
Wait, that's rare for.
Oh, what?
Such a
Oh,
short.
come on!
It's such
Alright.
a short group.
So 2.5 minutes this time, okay? Let alpha be acute. In any isosceles reason, 4 interior angles are this. Adjacent angles along a leg are supplementary and the legs are equal by definition. If in a dissection of a rectangle, look at any corner of the rectangle.
Yeah.
Exactly one tile occupies that corner. So the angle of that tile at the corner must equal the rectangle's corner angle, i.e. 90 degrees.
We are
Not sure, right?
anymore.
But in an isosceles trapezium, the only possible angles are alpha or 180 minus alpha. You know? Thus, we would need either alpha
Intelligence?
or 180 minus alpha.
Intelligence?
No.
Ow.
Yeah, I had like 5 more lines of working.
Therefore, it's not okay. So it says here ChatGPT can make mistakes. Check important info. I feel like ChatGPT should produce in its output how likely the answer is to be correct. You know?
No,
It's
but
like-
that like affects like, cause like if people like see that, like it hurts ChatGPT's reputation of being reliable. 2% reliable.
Yeah.
Can you ask it how reliable you think its truth is?
Yeah. Okay. What probability
Oh gosh.
would you put for this answer being
This thing's so
correct?
old. What do you mean it's so old? I'm trying to sign up to DeepSeek.
Turn off
And the
thinking.
question says when you're born. So old. When was I born? When were you born? I don't even remember when I was born. I don't remember when I was
I
born.
don't remember when I was born.
Being born is so cringe. That's what someone who wasn't born would say.
It's like getting worried now. It's like I didn't know I was under this much scrutiny. What the hell is this?
Let's start. Can we compare?
I just want to casually generate outputs. I don't want any pressure.
10 to 15.
What the?
10 to 15%.
Oh.
Yeah, but you can't tell that the answer because we haven't gone through it yet.
Alright. So, yeah, I guess we're kind of going to stop doing the ChatGPT thing. But, yeah, so the ones that the ChatGPT definitely couldn't solve are like 4 and 5. And I guess to be fair, it still has another 3 hours and 50 minutes to try them, I guess. But if it keeps outputting the answers that quickly, then it might never be able to solve them.
No, if it gets infinite attempts, then of course I can solve it.
Really? But it's not really getting deeper. It's just kind of doing this. So that's the issue with the AI approaches to maths. A lot of them, they just keep trying different things. But with what people do, is that they build on the first attempt. So like if something goes wrong, they use that to get the next attempt. Whereas the AI, they just keep doing different attempts. So one of them is like a linear kind of progress. The other one's like exponential, right? All right. What are you doing?
I'm putting it to DeepSeek, you know.
He's putting it into another AI. All right. So what I want to show you, I guess, is a interactive version. We only have like 25 minutes. An interactive version of Gregory's solution to this question. Okay. All right. So, I mean, ChatGPT wasn't completely wrong, and you guys also came up with this, right? If you have a rectangle and you want to tile it with trapeziums, yeah, you kind of want to put something in the corners, right? So you put it in the corner, and then we can put, like, say, 2 alphas in the corner here, right?
Yeah.
And what we can conclude from that, okay, is every corner, so 90 degrees, is a multiple of alphas. Does that make sense? Okay. So we can conclude alpha 90 is a multiple of alpha. Okay. Okay, but you have to be careful in justifying this because you can also have 180 minus alpha. Yeah? We noticed that too, yeah? But 180 minus alpha is obtuse when alpha is acute. So that can't fit in the corner. It's a 90-degree angle, right? So it has to be just alpha, so 90 equals a multiple of alpha. And we also noticed, okay, so be careful here. This does not mean that alpha divides 90. Remember that? Yes? Okay. It doesn't mean alpha divides 90. And you may want to think about why that is, but for alpha to divide 90, you have to already know alpha is an integer for this statement to make sense. Okay? But here, alpha is not necessarily an integer, so it could also be like 90 over 7 or something, right? So, but at least it's rational. This means alpha is rational, okay? But it doesn't necessarily mean alpha divides 90 as an integer. Okay. Okay. So this consideration, I'm going to tell you, is helpful to finding a solution, okay? So maybe I'll give you like a minute to think. I guess I only give you a minute 58 seconds to think about things now because that's the playing field we have to deal with these days. Like, if you think more than 1 minute 52 seconds,
Illegal.
your job is on the line. So I mean, this idea, like, sort of is very good. What are sort of all the manifestations of this idea? Maybe I could probably be less vague, but so I'm only giving you a minute to think about, like, is this the only way this kind of idea appears? Yeah. What other instances of this idea appears in this problem? Okay.
What do you mean by that?
So we conclude 90 is a multiple of alpha, yeah? Can we conclude like other kind of things like this based on fitting things into a corner or fitting things somewhere, yeah?
What's the Q stand for?
The set of rational numbers.
Alpha's less than 90.
So rational numbers are those that can be expressed as a fraction of integers. So notice here it's 90 over n. So alpha is equal to 90 over n. So that's a rational number. Okay.
An edge?
Okay, good. An edge, right? What happens at the edge?
180.
So an edge is 180, right? Yeah?
Yeah.
And you can put stuff in the edge, right? That makes sense? So we got the corner and the edge, right? The corners are 90 degrees, edges are 180 degrees, yeah? Is that all?
The points.
Okay, Andy's pretty good. Okay, so what are the points? So points are like
Intersections between like the two vertices are.
yeah, they're kind of just in the middle of the rectangle somewhere, right? That makes sense. So yeah. Yeah. Okay. So in some sense, the corners are 90 degrees, the edges are 180 degrees, and the points are 360 degrees. Yeah. Okay. Is that everything?
Probably.
Yeah.
The way you're asking this is gonna scam us. There's like 7 other ways you could.
Well, sometimes I have to just keep the meta game alive, right, and balanced.
That's what you always say.
If I don't balance the meta, it'll be too predictable.
That's what you always say. And
The
then
meta
it
is
ends up
always
being...
predictable.
Huh.
It always is never predictable. Therefore, it is unpredictable.
Yeah.
Which makes it predictable.
Ha ha ha.
It's predictably unpredictable.
Mm-hmm. Mm-hmm.
Why do we need to know that the edge and the point? Like, how does that help us? Something.
That's a different question.
Because like if you think about it, right? If alpha, like if 90 is a multiple of alpha, then alpha is like a 360 is also a multiple.
Yeah, so okay, that's a good suggestion. Okay, so what I've said is 90 being a multiple of alpha is going to help us, right? So that's like, it's almost like an assumption, yeah? You don't know why it's going to help us. But what this is sort of taking this idea to the fullest, yeah? This is only one instance of the idea, because there's more to the rectangle than just the corners, right? So if this is going to help us for whatever reason, then these are going to also help us for the same reason, okay? It's giving us a complete picture, you understand?
Yeah.
Okay, we'll go into why it's helpful a bit later, but we need to sort of try to get everything first, okay? We don't want to have like an idea and just have only 80% of it, okay? Okay, so how can we say we got everything? Well, we can think of it as every instance in which the vertex of a trapezium, right, is in the rectangle anywhere is covered by these three cases. Yeah? Does that make sense? So, it could just be like a bunch of vertices stuck together, so that's 360. It could be a vertex that's on the edge of the rectangle, which is 180, right? It could be the edge in the corner, which is 90. And I guess it could also be like a vertex that's sort of just on the edge of another trapezium, but that's also 180, right? Does that make sense? So, so these angles can also be broken up into alphas. Yeah? Does that make sense, Sebastian? So these can also be broken up into alphas, yeah? But what's the difference in these two situations?
One of them is alpha and alpha minus 180 minus alpha. The other one is just
Yeah, so in these situations, because remember we excluded 180 minus alpha here because it was obtuse, right? But now the angles are bigger, they might have 180 minus alpha, yeah? So here it could either be 180 equals a multiple of alpha, in which case we know it's 2n alpha, right? Yeah? Or what is it? What else could happen?
180 equals alpha plus 180 minus alpha.
Okay, is there any other way this could happen? So now there's another way it could happen, right? So it can be alpha plus 180 minus alpha, okay? Is there any other way this could happen?
Oh wait, no, it can't.
Do you understand what I'm saying now, Sebastian?
Oh, it can't.
Can there be a different combination of... So there's only two kinds of angles, alphas and 180 minus alphas, right? And here it's all alphas. Here it's one non-alpha and one alpha. Yeah? Are there any other combinations we have?
The other combination does not work.
Yeah. Why not, Esmond?
180 minus alpha has to be obtuse.
Yeah, and so therefore...
So therefore, two obtuse. So
it's too big, right?
Yeah.
It's too big, so if you have more than one, yeah, it's going to be more than 180, right? So you can't even have one here because 90 is too small. 180 is bigger, but it can't have two either, right? So if we can only have one, okay, the only other angle you can put in is alpha, right? And once you put alpha in, it's already 180, yeah? So these are the only two cases, you understand? Okay. So the proactive people would know what to do next, or at least what to try to do next, yeah? So the 360 case, yeah? So what happens in the 360 case?
You could just have 4 and alpha.
Yeah, so you could have 360 equals 4n alpha, which is just the first case of the other two as well, right? But what else could you have?
360 equals 2 times equals, what's it? 180 minus alpha plus alpha, no, 2n plus 1 alpha equals?
Okay, so 60 equals 180 minus alpha plus 2n plus 1 alpha.
Yeah.
Yeah. Okay, what other cases are there? Are there any other cases?
Probably.
Probably. So we have no 180 minus alphas, or we have 180 minus alpha.
2.
You can have two.
Can you have two?
Then you can have two.
280 minus alpha and 2 alphas.
So how do you have two?
Two and alpha.
Oh, yeah,
So 280 minus alpha plus 2 alpha,
Yeah, but two and alpha.
2n alpha,
No,
Just oh wait, no, just two alpha.
just 2 alpha.
Okay.
Yeah. Are there any other cases?
You can get 3.
You can get 3.
Just 3. If
See,
alpha
it's
is
about
60,
three.
you can do 3. Yeah, if alpha's 60, you can do 3, but it can't be actually. So. Can you 4, 5? No, you can't.
No, don't.
You do. Okay.
It's not just brain rot anymore. It's like it's a brain invasion.
Yeah, no, there's no other way.
Okay, do you understand how he got that? So he did a calculation on the scratch paper. But what did he calculate?
360 because 3
Okay.
times 180 minus 3 times 120.
How does the 2n plus 1 alpha become 2 180 minus alpha?
Oh, so the 1 alpha here goes with that 180 minus alpha to get 180, yeah? And then the 2n alpha gives you the 180, the other 180. Yeah. So here there's no n's. Okay, so basically if we look at this n alpha, yeah, n has to be at least 2, okay? Because you can't have alpha equals 90, yeah? So alpha equals 90 over n, and and n is at least 2, that means alpha can't be more than 45 degrees, right? Okay. If alpha is less than or equal to 145, then 180 minus alpha is greater than or equal to 135, right? And if it's greater than 135, 3 of them will be greater than 360. Yeah? So you can't have 3 of them. Yeah? So 360 is the biggest it can
I
be.
have a question.
Yes.
So if we go back to 180 equals 2 n alpha, right?
Yeah.
Why can't you have, like, for example, 180 equals 3 alpha or like 5 alpha?
You could, but that would just solve for n.
So n being like, like.
Because n is determined, right? Like that value is the same for the whole problem. You know. All right, so we've completely understood how the vertices of the trapeziums interact with other vertices of trapeziums. Yeah. Okay, so I'll give you the rest of the lesson, which is 10 minutes. Okay, the rest of the pre-dinner lesson. 10 minutes. See if you notice something about these cases that will lead to a grand realization. And I might give you a little hint towards the end.
Funny thing,
No.
I've been running DeepSeek. I turned on DeepThink and it's been running for 15 minutes.
Oh,
Oh no.
how inconsiderate of it. Actually, yeah, you should be able to set the time, the thinking time.
How's it going?
Alright, no, don't waste your only 10 minutes. This is your opportunity. Every opportunity is a golden opportunity. There's something to notice here.
I'm not noticing it right now.
It's not like, once you notice, it's not like you have to write like an essay. It's like, it's literally, it's like the aha moment. Yeah. So Tournament Towns, like, the aha moments are definitely bigger, and the kind of the writing and the gritty work is definitely shorter. Whereas in normal Olympiads, it's like a lot of easy little moments strung together. Yeah. Here's like a big aha moment right here. Okay, so the dinner's been delayed for 15 minutes. So you have a 15-minute time extension, but I can give you a hint. Okay. I mean, so the difference between just having the corners and having the edges and points is now we kind of really see how the 180 minus alpha comes into play, right? Okay. And so maybe I want some observation about how it comes into play, right? Like, so what do you notice about the alphas and the 180 minus alphas? Okay, so that's my hint. Oh, when did Lawrence get here?
First snuck into the lobby.
Yeah, so Lawrence said something about the number of angles, yeah? So here there's n alphas, yeah? Here there's 2n alphas, 180 minus alpha, 1 alpha, yeah? Here there's 4n alphas. Here there's 180 minus alpha, 2n plus 1 alphas. Here there's 180 minus alphas and 2 alphas, yeah? So, yeah, something about the numbers of the angles, okay? I don't know if I could actually say any more than that.
Nope, I haven't got it.
Huh? What'd you say?
I have not got it.
Oh, you have not got it.
So, have you seen a pen spring anywhere?
This is fall O level, not spring O level. Sebastian.
No, that's fine.
Yes.
Oh my.
Yeah, so basically, okay, so my final hint, and I hope this doesn't just spoil it, but stare at the things that are on the screen.
Sure.
Oh, I think Lawrence might have it.
So, one is cooking. Unlikely.
Okay, I won't show Lawrence's answer until you guys have something. So just like the 4 objects on the screen, yeah? And we're talking about the number of angles.
Maybe the number. Is there a connection between the number of 180 minus alpha angles and the number of alpha angles?
I mean, connections are always nice, you know?
Fine. I don't know, I think we might have. Was it? I'm not sure anymore. Now that I've said it. I want to say the number of alpha angles is equal to the number of 180 alpha angles.
Why is that?
That's just wrong. That is wrong, I think.
So,
No,
I mean,
one angle ruins it all. No, I was about to say that, but then I realized that the 360 equals 380 minus alpha. Like, this counts that. Maybe the number of 180 minus alpha angles is either equal or one of them is just 0. Oh, Jimmy joined.
alright, who just... Oh. Wait, Jimmy. Maybe turn away for the moment. I'll give you something else to look at.
Okay,
Um,
okay.
I'll send you the video for this, but you don't want to see the end of this yet. You want to see the beginning, okay?
Okay,
You
sure.
can look at SO4. Okay, I'll put the question SO4 for you. Can you see SO4? Just quickly.
Yep, okay,
So
thanks.
all right, so Jimmy, just do that and don't listen to what we're about to say. We got another 10 more minutes of this, okay?
I have to go now. Can you send me a solution for this?
Oh, okay. Yep.
Okay, thank you.
All right, bye, Audrey. Ten minutes.
Can't be right.
So all the stuff you were saying is relevant and correct. Yeah.
Is that it? No. It's saying suspense.
Sebastian said something about the number of angles. 180 minus alpha is equal to the number of alpha angles. Or is it?
Yeah, but like, it's kind of wrong because of like.
In this case, it's equal. Yeah. But in this case, it's not equal. Right. So this
Oh,
is.
I got it.
This is. Oh. So maybe you can make a different statement. You can relax your statement a bit, Sebastian. You need a statement that's true in all cases. So they're not equal, right? In all cases, yeah. Like they are equal in some cases. So what can you say though?
Good.
No.
That's one kind of time limit. It's the anti-clock.
Wait, maybe like the number of 181 alpha angles and the number of alpha angles are equal unless like there's only a singular one, e.g. only 2 n alpha or only n alpha or only 3
if.
180.
Isn't it? Is a better way to say this?
It's getting on the right track, unfortunately.
Unfortunately.
Unfortunately, Bro really doesn't like competition. Oh, freaked out and started writing that.
Alright, don't get distracted. So we know they're not equal in number, right? Necessarily in all the cases, yeah?
But maybe the number of angles is always a multiple, like a power of 2.
What?
Right. Am I right or am I freaking out?
How much time do we have?
Or is it just like not it?
We have like 7 minutes, so. Alright, how about this? So they're not equal, right? But can you see that there's always at least as many alphas as there are 180 minus alphas? Yeah? So here there's just only alphas. Here there's either just only alphas, or if there's an 180 minus alpha, there's an alpha as well, yeah?
How about the case is like 360 is equal to 3 times 180 minus alpha?
So you just weren't paying attention. There are no 3 180 minus alphas. We already explained that. Because alpha is at least 45, at most 45. So 180 minus alpha is at least 135, so you can't have 3 of them.
Oh yeah.
So these are the only cases. Okay, so in every case, there's more sort of, let's just put more in quotation marks, there's more alphas than 180 minus alphas, yeah? Okay, how is that significant for the problem? So remember, there's 4 things to stare at.
Contradiction. Because there's an equal amount.
Sebastian AI activated. What are you saying?
That's so dumb.
Okay, so that's why I drew this thing here, okay? If you look at the trapeziums, yeah? There's an equal number of alphas and 180 minus alphas,
Yeah.
right? So if you piece the rectangle up with these things and you counted all the angles, there should be an equal number of each, right?
Yeah.
But these is suggesting that there's actually not an equal number of each.
But what if you only use, like, for example, the edge?
Quarter has to have four extra.
Yeah, so
elements.
these could just tie, yeah? These could tie, this could tie, yeah? But the corners can't tie, yeah?
Intelligent.
The corners will always be more alphas than 180 minus
Does
alphas.
that explain why, like, every time we try to do it, like, for example, like, if we try to tile it, there's always, like, a small rectangle in the middle? Looks like it's kind of, like, cancel out the values in the corners?
Yeah, maybe. That's quite a nice solution, right?
Intelligent.
I mean, you might be a little bit worried because how do you know it accounts for all of the angles, right? But I guess literally these cases are defined at the vertices of trapezium. So anytime there is an angle, it has to occur at this because by definition, these are where all the vertices of the trapeziums are. Yeah? That makes sense?
Yeah.
So the angles, they can't just exist out of nowhere. So the one thing I guess you might want to be careful of is this edge is not necessarily the edge of the rectangle. Yeah, it could be the edge of a trapezium as well. If that makes sense. But the point is it adds up to 180. Yeah? So it's any place there's a vertex of a trapezium, which is any place where there is an angle, right? So that means it has to account for all the angles, right? And if it accounts for all the angles, then there has to be an equal number of like 180 minus alphas and alphas. Because every trapezium, there's only 2 of each, right? But no matter how you do it, there's always going to be some corners, and you're always going to get more alphas than 180 minus alphas. Does that make sense? That's pretty cool, right? Yeah.
So unintelligent. Oh, so by the way,
Has DeepSeek finished thinking?
Yeah, finish thinking a while ago.
how do I phrase it?
It sort of crashed out.
So I'll say the very last paragraph. This is what it looks like. Wait, hang on. Now that is blah blah blah. Or consider a tiling of a rectangle by that would be related to, that would be related to, that would be related to, that would be related to.
It started going into a loop.
It just
Oh.
splashed out.
Chase, let's go.
It created insanity.
That would be related to, that would be related to, that would be related to, that would be related to,
Yeah.
that would be related to, the relation that would be related.
Also, if this is how long I think. This is like mine. This is like a 10, and I just think with this one.
Yeah, I think it's funny how when people don't know anything about math, they think math is like the first thing that'll get replaced by AI. It's
No.
literally going to be the last.
English is gonna get replaced by AI. Obviously. So what are you doing?
Circling the alpha.
Too many circles.
So I guess you could say you need to circle me now because I'm the alpha.
Ah, Sebastian. Alright. Does anyone have any questions about this? Alright, it's pretty neat, right?